Okay, so here's the question, right? Let's say we have a cube, looks like this, and let's say we have more than one. And you know what? I'll just make up a couple other values. Okay, so here's their true values, and let's say, okay, so let's say we measure them on each of these, or we measure a different one on each one. So let's say we put the 17 gram one on this scale. So the readout that I'll get is 17.5298. Okay, and I put the 56 gram one on here. The reading I'll get is 56.43 grams there. Now the first question is, what's the uncertainty? Okay, so the uncertainty on a digital device is just equal to the last readable digit. So plus or minus 0.1 gram. Okay, why is that? Well, because if I look at the next value over, right, it's either going to raise this up one or it's going to keep it the same. So the plus or minus 0.1 grams accounts for that next unknown digit and what it might be. Okay, here plus or minus 0.01 grams, and here plus or minus 0.0001 grams. Okay, so if we were to say, what is the sum of these values? Okay, there's a sum I would get if I added all of these up, but I don't know those, right? I can only know the values that I'm given. So 247.7 plus or minus 0.1, 56.43 plus or minus 0.01 grams. We're going to add those up, and we're going to add to that 17.5298 plus or minus 0.0001 grams. So if I add those all up, let's type them into the calculator. 247.7 plus 56.43 plus 17.5298. My calculator gives me this value, 321.6598. Really? Oh. Okay. Grams. Okay, so we'll just ignore the uncertainty for a second. And that's what we get in grams. So the first thing is, okay, why can't I write this? Why can't I just leave this like this? Are these values going to be correct? No, they're not, right? If I look here, this actually wasn't even a 7. It was a 6, 5, 3, 2. But I don't know these values, so therefore I can't carry down through my equation and write them here as if I did know what they were. Okay, and there's a 2, 8 there that we're ignoring, and then we actually do know those values. So the first thing we have to do is understand how to deal with the rounding of this. Which digits are significant? Okay, so when we're adding, the rule of thumb is you just round to the input value with the lowest value after the decimal place for the lowest readable number. Okay, so in this case, that's this digit. So we look at it and we say, okay, 3, 2, 1, 6. After is a 5 with a number after it, so we go to 7 grams. Okay, and then there's a plus or minus here because each one of these included some uncertainty. So what we could do is we just add the absolute uncertainties, and you'll see something interesting here. Some of the uncertainties are very small, and therefore they swallow up some of the larger uncertainties. So we get plus or minus 0.11001, but it doesn't make sense to have an uncertainty value that has more digits in it, more precision in it than this, so we just round back to this. Okay, so that just stays as 1, so 321.7 plus or minus 0.1 grams. These smaller uncertainties here are swallowed up by the larger uncertainty. Oh yeah, I did, sorry. It doesn't matter. It gets swallowed up anyway because we round back up to just having an equal value here. So this is how we would deal in this case where we have a whole bunch of input values for adding or subtracting, and how to deal with them if we have different precisions for each of them.